Hi, everyone. Thank you so much for joining. And special thanks to the people behind the Global XR Bootcamp for giving me the opportunity to talk to you about my favorite subject, WebXR. I'm SourceCoot, but you also might be able to find me by the name Timmy Coca on LinkedIn and on IRL. I'm a senior mixed reality developer at Velicus, and when I'm not working, I stream development of WebXR apps and games a couple times a week on Twitch. I also run a WebXR meetup in the Netherlands, and I help running the global WebXR Discord. If you want to know more about that, you can go to WebXR to find out. Today, we are going to build a simple WebXR game that runs on Edge on the HoloLens. We're going to start with a little bit of an introduction of A-Frame. Then we're going to get that app running on the HoloLens. I'll talk a little bit about what it takes to do that. And finally, we're turning that little demo app into a game. So let's start with WebXR. So WebXR is an official W3C web standard. It is basically a set of APIs that provides access to input and output capabilities associated with VR and AR. It allows you to develop and host VR and AR experiences on the web. A-Frame is a declarative framework to build VR and AR experiences on top of WebXR. And one of many. There are a couple others like Babylon.js. But I think A-Frame is one of the easiest to get started with. It is cross-platform, as the web is by default. And it's component-based, which means that you write components and attach those to entities. It also comes with a built-in inspector for very easy debugging. Yeah, so let's go over the basics of A-Frame a little bit. This is an example of a piece of A-Frame markup, which looks pretty familiar to HTML. Actually, if you place this HTML inside your HTML document, it just works. So let's zoom in a little bit further and dissect this example a little bit. Everything inside of A-Frame is wrapped into an A scene. And for example, we have a couple of primitives like the A sphere, which has an opening. Then we have attributes and attribute values. Most often these attributes will reflect to components. And of course, at the end, we have a closing tag. Here we have a simple example of an A-Frame component. It's very small, but to be honest, there is a lot of stuff in here already. And if you know what's going on here, you can just build from that. So every component has to be registered with A-Frame for it to work. It has to have a name. In this case, change color. You can give parameters to your A-Frame components through the schema. These are basically the attribute values you can pass. You can give it a default. So in this case, when there's no value for color given, it will be green. And you can give like strings or integers or vectors as parameters for the data in the schema. Then there are a couple of lifecycle functions. In this case, there's only one, the init. Often you will have a tick and an update as well. There are a lot more, but personally, I don't use those too often. Then there is, you can reference to the element this component is placed on. You can do that by calling this L. And you can just add an event listener, in this case, an event listener for click. And when this element is clicked, we can change an attribute. In this case, we set the material attribute to a specific color. Now let's recreate this, and let me show you how this works in an actual application. So let's switch to the desktop. So we're here in my Visual Studio Code, and there's nothing special about the project I've set up. It just saves a little bit of time. I've got a SSL certificate set up, and in my package JSON, I set up a simple HTTP server to be able to run the application more quickly. I'm going to start the application by creating a new file, an index HTML, and we drop an index HTML template in here. And let's name this a frame demo. We need to have the A-frame script reference in here. I'm just taking the online version. And I want to have a very simple scene. Now, I've set one of those up already. This is the same scene we have seen on the previous slide. With the box, a sphere, a cylinder, and that plane. Now I should be able to save it. And if I switch to my desktop, we can have a look at what it looks like. So I'm here in my browser. I didn't change the location of the camera, so we're actually standing in the middle of our little scene now. And you might notice that I didn't set up a camera. And that's one of the great things about A-frame. You get a lot of things for free, like the camera, like the lighting. There's default lighting in your scene. There are a default camera in your scene, and that way you don't have to do a lot to get started. Just create a cube, and you already have a cube on your screen. Now let's make this a little bit more interesting and add a component that will send the click event to change the material when we look at something. To change the material, we need to add a component. To do that, we add a file, new file, and we call this change color component.js. I always like to name my components in the file so I can see the difference between files that have a component and files that don't have a component. I've got a code snippet I always use for my components, which has the basic functionality in there already. Call this change color. And I'm going to delete all the functions I don't need in this case, which is basically everything except init. We need to add the color to the schema. So we do color, and we give this a default of green. Now we need to set that color to something we click on. To get access to the element or the entity that this component is on, we can use this.l for the element. And now we can do add event listener. And we do click. Now I'm using an arrow function here because that way I keep the context of this. Let me say this L. Now we need to set an attribute. And this attribute actually references some other component. In this case, it's the material component. And of that material component, we want to set the color. And of that color, we don't want a string. Let's go away with IntelliSense. We want to have this for the current element, for the current component. Then we go data, which reference the schema, and then we do color. Now we need to load this in our main document. So we go and add a script reference to that color change. And now we can apply this to certain objects. Well, let's not do the sphere. Let's use the default green for the box. So we see that working, and we do like color pink or something for the cylinder. Now we might want to move these out of the way a little bit because they're pretty close. So let's look at the position. This is 1, so this is 1 meter in front of you. Let's move them. Let's try -4. So this is 1, 2, 0. So they're 0, 0. Okay, so let's do -4. That's a little bit far away. -2, 3. Let's all subtract 2. Okay, save. We also, to be able to send the click event to something, you don't always have tracking. So one cool way of doing the click event is using a cursor. Now to use the cursor, we actually need to add the camera to the scene because the cursor is related to the camera. So we create a default camera with loop controls and WASD controls so we can move around at a position just a little up where we could be standing. And then in here we have the cursor. This has a fuse and a fuse timeout. And this just sends the click event after 500 milliseconds. It has a position 1 meter in front of the camera, some geometry, which is a ring. It has a material, just flat and gray. And it has an animation. Now when we click, it plays this animation, which is just a very quick scale back to where we were. Actually, this is 1.5 seconds, and I noticed this is half a second, so let's do this. And when we fuse, so the time we are looking at something for 1.5 seconds, it just shrinks, and then it clicks and pops back. That's what the animations are doing. So let's switch back to the browser and see how this works. Now let me refresh the page. There we go. You can see the click event. Nothing happens on the sphere. But I'm really, really curious what will happen if I look. Oh, it's green. So this one should be pink if we click. It's hard to see, but it is pink. It is a very, very light pink. So this works. Now that we've seen the basics of creating a WebXR app using A-Frame, let's see what it takes to run it on the HoloLens. There are a few things that we need to keep in mind and issues we might run into. For this talk, I'm focusing on Microsoft Edge, which comes with the HoloLens. The tricky thing is that on desktop, Microsoft has implemented Chromium into Edge, which enables a lot of features from the WebXR device API. On the HoloLens, there is still only a UWP version, like the old Edge, but it has the complete WebVR 1.1 spec implemented. There's also a version of Firefox Reality, which has a better implementation of WebXR, but it requires an extra app to be installed on the HoloLens. And for the sake of simplicity today, I want to focus just on running WebXR on Microsoft Edge. One of the first things you might run into when building web applications for the HoloLens is debugging. When building apps for example, the Oculus Quest, you can use the remote debugger to remotely view what's going on inside the app. And you get a similar experience like you would have when you are debugging just locally on your desktop. In Edge on the HoloLens, this is not possible. Luckily, there is a solution with the name Vorlon.js. Vorlon can be installed on your development machine using npm. And to get it to work, all you have to do is include a script link, start Vorlon, and then you can open the Vorlon page on your desktop and remotely over a network connection debug your app. Let me show you how that works. So we're back in Visual Studio Code. And in here, I'm going to go to my terminal and start Vorlon. Now I did just do an npm install Vorlon globally. So now in every project I can start Vorlon. With this running, we can almost start debugging. Let's close that window again. We also need to include a script. And this is just a reference to that local script. Now I've set it up on a domain name, which actually looks at my local IP address. So whenever you see coder.nl, it's just my local IP address. I need to specify the port Vorlon is running on. It's 1337. And we need to do vorlon.js. Close it. And now we save. We should be able to start debugging. Now it would be fun if we can actually see something. So let's go and in here, and just when this gets initialized, we write something to the console. So we do console log. Let's write hello. So we should technically see 2 times hello. Oh, you know what? Let's do something else. Let's do hello. And let's add the material color. So we do this data color. So we should see 2 of these because we used the component twice. Now let's switch to the browser. And let's go to Vorlon. Now nothing is running. So what I'm going to do is I'm going to switch to the version running on the HoloLens, because it's just a domain. I can just open the URL, and then we should be able to pick it up here. Let me refresh. And we'll have a look at the application in a second. There we go. You can click here. And as you can see, we have a connection coming back from the HoloLens with both these 2 objects. And this way we can remotely debug without having access to the device itself. We cannot do anything. We cannot attach a debugger in a normal way, but before long we can go into a lot of things. And this is how I got access to a lot of stuff and figure out how things worked on the HoloLens. So we switch to the HoloLens, and here we have the app running. We open it, and there we go. Now you might notice there are a few things wrong with this application. The background is completely white. The gazing or the fusing works, but we actually want to have the background removed, and everything is pretty big into my face. So let's stop this and fix that. So we're back in Visual Studio Code, and the first thing we're going to do is remove that white background. We can do that by going into the background on the scene. You can also use this to set a color if you like, but in this case, we're going to set it to transparent, and we set that to true. Now to scale down the scene a little bit, we're going to add an entity, an A entity to be exact, around our demo scene. I'm also going to change the color a little bit, just fun. Let's make this one blue and the other one red. And you know what? Let's add a little shadow as well. We also need to set the scale in this entity. So we do scale because we want to scale it down. Let's do 0.2. Now it's scaled down, so the positions in there will change. So we set the position of the whole thing to say 0, 1, move it up a little bit, and a little bit further away. And we also need to update the position of everything else. So let's do 3, 5. I don't know. We'll see what will happen. 3, 4 or something. And I think that's it. Let's see how this looks on the HoloLens. There we go. As you can see, it's scaled down already. Let's switch to XR mode. And there we go. As you can see, it is transparent now. We can move around, we can walk around. And if we look at the cube, it's red and it's blue. and the circle still does nothing. Okay, let's go back to the code and see what we can do there. Great. Let's convert our sample application into a game. Let's build a small whack-a-mole type game with cactuses and cupcakes called Cactus and Cupcakes. Of course, we need to do hand tracking, because who doesn't like to grab a cupcake and who wants to grab a cactus, right? So hand tracking is in WebXR and in A-frame, but it's not in the version that is in Edge. As I said earlier, the version of Edge on the HoloLens is still the older UWP version and not the Chromium version. Will it work? Yes. It doesn't work with the tracking of the individual fingers, but we can get the location and the AirTap event through the Gamepad API. Now, through some debugging with Vorlon, I found the IDs needed to give A-frame and specify a custom controller. And by specifying a custom controller, we just can use the normal A-frame pipeline and specify the IDs. So let's add the controllers to the game. Right, we're back in Visual Studio Code, and the first thing we can do is just remove the whole camera thing we added to create the fusing, because now we're going to use our hand. There are a lot of different tracking mechanisms in A-frame, but in this case, we are going to add an entity, and on that entity, we're going to add a tracked controls component. The tracked controls component is kind of like a base component for other components. Like if you have the Vive controllers or the Oculus controllers, those are basically inherited from the tracked controls. This is the root one, so to speak. Now this has a lot of functionality in here, which we can specify like specify the controller we want to use, basically. So we do a track control. We need to set the controller property, and the controller property has the ID of the controller we're going to use. So this is looking into the Gamepad API, and this is what I was talking about. The IDs I got through Vorlon. These are those IDs. So we have ID 4, which is our left hand. So let's actually specify we have the left hand. And to make sure this is the right control, we can specify an ID prefix, because every control has an ID inside the Gamepad API. And we want a control that starts with hand. I don't know the complete name from the top of my head, but it started with hand, so that's what we need to add. In here, we're going to add a component, a model that is showing the hands. Now in the end game, we're going to remove these again because I want to see my real hands. But to see the tracking work, it's easier to see if there's a 3D model of a hand on top of the real hand. So we're going to add another entity. And we name this ID, or we give this an ID left hand. And I'm going to give this a rotation. And these values just came from trial and error, just doing it again and again and again. Also, the position. Let's reformat this a little bit. I'm going to add a position just to slightly move the model from the position where it's added. And the problem or the downside of doing it like this is that every tracking, if you have another device, for example, this whole thing might work on a Magic Leap, but these values probably are different. So this is the new position. Is that correct? I think it is. And I'm going to add a GLTF model. Not use the snippet. And I'm going to copy the URL. Now I'm going to use the default A-frame model. I'm not going to type the whole thing. So this is just a reference to the left-hand low GLB file to put it on the hand. We also need a right hand. So let's copy this whole thing and rename a few things. Of course, we want this to be the right hand. I believe the prefix is the same, but this is going to be right. And the ID is the one next to it. Also, this has to be right hand. And I think the rotation was different as well. Yes. Position is the same. So this should be fine. I think these are the hands. Now to get the hands to actually do something, because we want to touch something, we can use a collider, but a collider is pretty heavy on the calculations. There is a simpler way of doing this, and that is using a ray caster. Just cast one single ray, and if something is touching that ray, we get an event, and we can listen for that event to anticipate on it. So let's add it to the right hand. So that's we're going to add the ray caster, and we start, or we start at 0, and it's going to end at 10 centimeters. So it's only a ray of 10 centimeters, just a very small ray, but it's just long enough to just be kind of at the end of your hands. Now I don't want to check all objects in the scene, because it could be a very big scene, and then it needs to check the ray against all those objects. So what we can do, and that's funny because it's still HTML, touchable. We can use a CSS class and filter against that. We're going to set show line to true, so we can see it in the UI. In your production code, you might want to turn show line off, but now I just want to see that it works. Although we might be able to see it running from the hands, but okay, now we need to add something that we can detect that we actually touch something. So let's add another component. And let's call this collider check. The component.js. Let's add a quick component. Collider check. We don't need to have a schema in this case. We don't need anything except the init. And in here we're going to add another event listener. And we are, did I write it correctly? Event listener. I think it does. Why don't I get the, oh, there it is. And we need to have the raycaster intersection event. Let's do it like this. There we go. In here, we have event parameter. Let's grab something that is coming in. We want to have that element we intersected with. We say e detail. In A-frame, if you have an event, stuff that comes from A-frame is always in the detail object inside the event. And we do else for the elements, and we just pick the first one. And what we're going to do is emit the click event on the element we intersected with. So now we have the default behavior for clicking, except it triggers when we touch something. So we can send a click on a touch. Last thing, before I forget, we need to add that class to everything that is touchable. So the box and the cylinder. I think this is it. Let's run it on the HoloLens and see if it works. There we go. Let's switch to VR to get the immersive experience. And yes, there we go. So you can see my hands. Let's see if we can touch something. So we can touch the cube. There we go. With the other hand, we touch the cylinder. And there we go. Let's go back. Let's convert this into a game. First step we're going to take to convert this into a game is adding our third and final component. This will be the game component. This game component contains all the game logic and the game state. So again, we do a component. And let's just call this game. I think that's fine. We need to make sure this is also on the scene. It doesn't really matter where the game component is. I like adding it to the scene. We don't need we don't need any of this. We will be reusing the logic, but we don't need this. For the controllers, we are using the controllers, but I want to see my hands. So I'm going to remove the model. Everything else stays the same. So this will be an empty kind of empty entity, and which has that raycaster in. So I'll leave that on so we can see where we are pointing with our hand, if it's working correctly. And there is something wrong there, I believe. That looks odd, but let's just fix it as we go. Okay, so now we have a left hand and a right hand without any models. We do need a little bit more. Let me grab the assets really quickly here. Let's see, where are they? Because I have 4 of them. Can I drag this in here? Yes, I can. So we have 2 screens, a game over screen, a title screen, and 2 models, a cupcake model and a cactus model. I cannot show them here because they are binary. So all the textures, everything is baked in. So we have those. And now we need to load them. Now, what I like to do, let's drop a snippet in here. What I like to do is just add them into the assets. So A-Frame has an assets entity where you can place your assets in. We have 2 asset items, which is the cactus model and the cupcake model. And because these get an ID, we can just reference to these models by ID. There's 2 other things in here, which is a mix-in. And a mix-in is something pretty cool, I think. It is something where we can have a predefined piece of code or markup, and we can mix that in with other markup. So if we want to have a cactus thing inside another object, we can just say, well, we want these properties here and take those. This has a scale, and this has a reference to the model. It also has that touchable class, so they should be touchable. In here, I also added the title screen and the game over screen. Both are just a plane placed a little bit in front of you. They are transparent. The game over screen is invisible. Visible is set to false. And because it's just a plane, the images are transparent. So you see this text floating in front of you. We could do this a bit better, but for the sake of simplicity, I did it this way. We could do 3D models. We could do different images and stack a couple of planes behind each other. What I like to do is rotate the planes as well. So when you see text, it is slightly rotated, so it's more apparent that it's three-dimensional. I also added an entity with text, which is empty, but this shows the score we have. Now there is one other thing we need to add to this, and let's do a snippet again, and those are placeholders. So I created 3 placeholders. These placeholders are sitting in front of you, and I need to imagine that if you play the game, on the place of the placeholders, that's where the cupcake or a cactus will be. When the game starts, there is already a cactus and a cupcake there. And then when the game, when you play the game, these entities will be added by the game object. And I think that's it for the markup here. Oh, we need to load the game component. Let's not forget that, otherwise it won't work. So yeah, let's start and go into the game. So we need a schema. I want to have a spawn time with a default of, say, 2000 milliseconds. Let's clone this. I want a cactus chance. So this is the chance of a cactus spawning of 0.2. Now, the fun thing is, we can just change these values. We can even change these values from the inspector, which is pretty cool. If you look at the inspector and there's a component, you can just see the properties and you can change the properties of the. So if you want to test this with different things, it works really well in the inspector. Let's just clone this again. It's way faster. Entity lifetime. So when we place a cupcake, that cupcake will stay there for some time. And for now, let's just set that to 1000 milliseconds, which is 1 second. And then we have one more complex property on the schema. And this is the game state. And this is one off. And one off can only have a value from this array. So we have a title for the title screen. We have state playing. And we have a state game over. Now we can set this to a default as well. Let's set the default to title. So we start on the title screen and schema change is true. So when the state changes, we want to trigger a schema update. I don't think we need the updates, and I don't think we need any of these. Let's go and have a look at the initialization function. I want to have a countdown timer. We do this countdown, and this is just the spawn time. Data spawn time. So when the game starts, we do a countdown. Every time this countdown reaches 0, we spawn a new entity. So we just run this every tick and use delta time to subtract from the countdown. And when we reach 0, we spawn something and we reset it to countdown. But we needed to reset it initially. Then we need to get the targets. Now this is just HTML. Let's make it a bit nicer. We do a document. Query select all. Placeholder. This. So now we have a list, an array of all the placeholder elements, which are 3. But if we want to extend this game, we can just add a placeholder to the game somewhere, and it will just be picked up because it's in targets. Let's drop these in very quickly. We grab 2 more elements, which is for the title screen, and the game over screen because we need to turn them on and off. And I want to start the score at 0. When we start the game, score should be 0. Now, one thing we also need to do is trigger something. When the game starts, we need to trigger something to go play the game. Which is a button down. We just grab the track controls, and for every track control we can find, 2, we listen for a button down event. And when a button down event happens, which is the button down event of the gamepad API, which is just an AirTap in this case, we check if we're on the title. If we are on the title, we go to playing. We set the title screen to false. We set the game over screen to false. We clear all the targets, set the score to 0. We update the score, and we go play the game. Then we have the game loop. This is the part where we spawn all the enemies, or the cupcakes and the cactus in this case. If we're not playing, we just ignore it, and we don't need anything to do with the game, with the tick if we are not playing. We're just on the title screen or the game over screen. Then we subscribe the countdown, and if we reach 0, as I said before, we just pick a random number between 0 and the target length. If it is empty, so if we spawn at a position and there is nothing there, we create a new A entity. We check the chance for the cactus. If it is the cactus chance, then we create a cactus. We just set the attribute to mix in cactus. So we get all the things we set and it mix in. We get it in here. We add a class to that entity of cactus, so we can easily identify that object, the entity. Otherwise, we do the same with cupcake. And we set a destroy. I need to remember to add this object, by the way. And this is just deleting. It's a very simple game object. I have in every game I have one of those. At a specific amount of point in time, it just destroys the entity, and we make sure it has the class touchable, and then we just append it to the target, and then we reset the spawn time. Now the last thing we need to do, I think we have a couple of more functions here. We need a function for game over, we need a function for scoring, and we need a function for update. When we are game over, we need to show the game over screen. Score, we just increase and update the score by that element, and we just set the text score with that number we have. Then we need to update this. We were emitting a click event. We're going to remove that. And for now, we're just going to check if it's a cupcake. Then we score. If it's a cactus, then we run game over. And in both circumstances, we remove the object from the scene. Now let's quickly add that destroy object as well. Destroy component JS. So here we have the destroy component. It's just a countdown timer, and when we reach 0, we remove the component. Let's go to the index. Make sure the destroy component is loaded. Let's save. Let me quickly check if I have everything. I think we do. Yeah. So let's head over to the HoloLens and check it out. See if it works. Okay. So we are here. The game seems to be running. Let's go into VR. There we go, our total screen. Okay, so let's AirTap, and there we go. So now we should see cupcakes. There we go. Let's grab one we missed. Oh, no, not the cactus. Yes. Another one. Oh, almost got the cactus. And I think it's working. Let's try the other hand. Okay, I think it's working. Great. and a game over screen as well. Okay, so it's working. And there it is, a fun little game running on the HoloLens. I've put all the code on GitHub. Do with it what you want. If you build something cool, let me know. Yeah, and that's all I have for today. If you like to know more about WebXR, you can find me at these locations here. Yeah, and make sure you go to the last to the WebXR NL and click on the Discord link to join our Discord. So yeah, with that, thank you all for watching, and maybe I see you in the next one. Bye bye. Take care.
Hi, Timmy.
Hi Hank. How are you doing?
Hi. I'm doing well. You're also still awake
Yes, I am.
on a Friday evening. That was a great talk and a really good example on how to actually build it. I think I can actually do that too.
Yes. If you don't mind, I like to. I mentioned the GitHub URL, so let me drop that in the chat as well. So if anyone wants to try that code, it's just on the GitHub and just yeah, it's there just to play with and see how it works. If you, I went to it pretty fast, so yeah, all the code is there if you want to explore it, and it actually runs in the browser as well. Except you cannot use the hands, but it's easy to modify back to a browser game. That's pretty fun.
Perfect. I think there are a few comments or questions in the chat, so let me pull them up. So
sorry.
The first one is now on the screen. Is there anything we have to do to set up Visual Studio for using A-Frame?
No, I'm using Visual Studio Code, but it's basically just a website. If you can build this in any editor. I like to use VS Code, but if you want to use Notepad or whatever tool you like, Vim, I don't care. If you can write text, you can write an HTML file and you just reference the script link and you can build it. Yeah, it's very easy to if you can build an HTML page, you can build WebXR. That's as easy as it is.
So that answers also this question. Visual Studio for Mac for such a project.
Yes, there is. There's one downside. Well, I think you can run this on Safari as well, but you can. It's not completely fully supported on iOS. So, but you can run it on different devices. Someone's mentioning the Quest. Yes, you can run this on the Quest as well. This is one of the first things I've built for the HoloLens. Normally, I would build things for the Quest. Yeah, I built a lot of little games. They're also on the GitHub as well. If you look around, little games I built for running on the Quest or the desktop or whatever there is. You can just run it everywhere where you have a browser.
Perfect. So if there are more questions or remarks, please put them in the chat. This is your time to ask them.
Let me share this link as well. I share a link to the WebXR Discord. If you want to know anything about WebXR, that is a great place to find information. It's just we're trying to get this to be the global go-to place for getting WebXR enthusiasts together. We're almost at 500 members now, which is pretty awesome.
And it are members from all over the world.
All over the world, yes. Yeah.
That is great. I don't see any new questions coming in, but I would recommend to maybe indeed go to the Discord channel or even now go to the Altspace VR room. And I don't know if you are going to be there. Are you going to be there, Timmy?
Yeah, I think I'm going to check it out. I'm going to grab something to drink and then I'm going to check out the Altspace. I see Joost is asking a question. How much years you think before we can ditch Unity for WebXR? Well, we don't. I think in a few. Well, you can actually build WebXR in Unity right now. So it's just a matter of time before Unity fully supports WebXR. People are building things. I'm actually amazed that it's not in there. One of the people working at Unity, Tony Parisi, has built, or is one of the founders of VRML, It goes way, way, way back. But he was building, he kind of invented VR in the browser. And he's working on Unity right now. So yeah, it should be at some point. It has to be. Just, yeah.
Perfect. No more questions coming in, or are they? No more questions coming in. So then I would say maybe we continue the discussion in Altspace with some virtual drinks.
Someone mentions the well, the easy thing is I use the name source code. That name right over here. This name.
Yes.
If you go to GitHub and use that name, if you want to do anything, if you want to find me anywhere, just use that name. If you want to find me on Twitch, Twitter, whatever, use that name. YouTube, I'm everywhere on that name.
Okay. Yes. We can find a link for your GitHub and put it in the chat. I don't know if.
Yeah, I shared it in the chat, but I'm not sure if it shows up. Maybe it's blocked by.
I don't think we can. If a non-moderator, you can share links. So I should be able to do that. I will just share your complete GitHub repository. Yes, this seems about right. Now we should be able to see it, I think.
There we go. And then this game is called Cactus and Cupcakes, but other games are in there as well.
There's a lot of stuff in there.
Yes.
Okay, yeah, I found it. Here it is.
Great.
Now we should be able to play around with it.
Great.
Perfect. Then thank you so much for your time putting this talk together and sharing the code, being in the panel, being in Altspace, being here.
Yeah. Just trying to get people to use WebXR, I guess.
Perfect. It seems like a very great tool.
Yeah, if you like the web, do you like? You might like WebXR as well.
Yes. So this is it for me. Goodbye, everyone, and thank you for watching. My dear colleagues are going to take over for the rest of the 24 hours. I can get some sleep. Enjoy the rest of the bootcamp. Thank you. Bye-bye.
Thank you. Bye-bye.